Okay, so do you see? You don't see it, right? Maybe I can change fonts. Font. Maybe I can make it bigger. 18. Better? Still don't see? Do you see it or not? So let's get familiar with MATLAB, okay? You have clear and you have a equals 1, okay? Notice that if I don't put this thingy here, semicolon, it gets printed out. How do I run the program? I press F5, and in Mac I press function F5, okay? To whom it is totally new? To some of you it is totally new, and you are happy, right? Please ask questions. Yes? Yes, okay. I have to make it even bigger. Let's make it even bigger. Is this better? No problem. So a equals 1, let's say b equals 1, and if I write a plus b and type F5 or run the program, it's 2. Okay? Any questions so far? No questions. So now I want to write a program that gives me prime numbers. Okay? For example, let's go for n equals 1 to 100. I will erase this. I will type just n and write down end. Okay? What will happen if I run it? You will get n equals 19 for 95, 1, 2, 3, 4, all the way up to 100, right? Well, what is the definition of prime number? Anyone can tell me? When it can be divided to only itself and 1, right? No other divisor, right? By the way, let me also show you that this is the editor, okay? This is the command window, so I can just type here n, for example, and press enter, and it will actually run that line, okay? For example, if I write n plus 1, what will be the output? 101. Does it make sense? So I can simply write it down here and press enter, and it will run that line of code, okay? So let's learn what is mod 5 to 2. What do you expect the result to be? 5 mod 2? 1. Everybody agrees? 5 mod 2, 1. If it's 0, for example, 5 mod 5 is 0, or 10 mod 2 is 0, then it is actually divisible by that number, right? Are you with me? Is it too slow? No? Okay. Let's now do the following. So we choose a number n, right? To find out if it's a prime number or not, we have to look for every number between 1 and n. And if there are more than 2 occasions in which mod is 0, then it has more than 2 divisors, right? It's a prime number. Okay, then it's not a prime number. Thank you very much. For m equals 1 to n. Okay, I have two loops now. By the way, I'm writing the worst prime number code there is, okay? Because I want to show you something. This is really hard teaching this way, by the way. Okay. Do you understand this line? It will go from 1 to n. And let's have something here that counts all the occasions where mod is 0. Mod, do you understand what I mean? Right? So, okay, I will write down here if mod n m equals 0, then t should be t plus 1. Well, I could have learned much more of coding, but I lost everything. When I first saw this, I think I was in 7th grade. And I had a friend who spoke really, really fast, okay? He said, I didn't get it, and I wasn't embarrassed to ask again. I asked again, and I didn't get it again. So, yeah, because it defies logic, right? How t can be t plus 1, right? Then what is the solution for t? No number can go there. The thing is that in coding, at least in MATLAB, you first do the right-hand side, and whatever you get, you assign it to the left-hand side. Okay? Does it make sense to everyone? So then it will count all the occasions where n is divisible by m, right? Then after doing all this, what is the condition for a prime number? What should t be at the end of this loop? 2. Everybody agrees? Very good. If t is 2, then I will just type n. End. Okay? Should I run it? There you go. You have all the prime numbers until 100. Okay? How can we improve this code? Okay, let's do the following. This is again for the purpose of teaching you something, not for the purpose of learning primes, right? Introduction to coding, we start with prime numbers. Are you happy so far? Yes. Okay. So let's have, by the way, MATLAB is not mathematics lab. Otherwise, there would be an H there, right? What is it?
Matrix.
It's matrix lab. So we will work with matrices all the time in MATLAB. So let's define something. Okay, let's define S. Let this S be 0. Okay, and every time I find a new prime number, I will do this unlogical operation again, S equals S plus 1. And I will assign it to S element of P. I should have reused some other letter. Do you understand what I did? No? So S is 0, right? At the beginning. Then, while this whole thing is going on, every time I find a new prime number, I increase S by 1, right? And I say that now the S element of P is prime. number, and it's equal to n. Let me just run it and you will see the result. I ran it, and here, by the way, do you see it? Here, there is my workspace, okay, workspace, which gives you all the variables that you have. And it tells you the value if it's just a number. And if it's a vector or a matrix, then it tells you what is the dimension of that matrix or vector. In this case, it's a vector, P. I don't know how to increase these fonts. Let's check fonts. No, not use system fonts. Use. Ah, there you go. Yay. So now you see better, right? So you have this workspace. Still, these letters didn't get bigger. That's just what life is. Then, do you see this one? P. It now has all the prime numbers in it. Are you with me? You understand this point? Okay. Now we will do the following. What should I do next? Let's do the following. Let's find, instead of numbers, prime numbers that go from 1 to 100. Before I do that, I will do something else. Okay. What if it's 10,000? Okay. I look for prime numbers between 1 and 1,000. Okay. And I will do the following. Time equals CPU time. Okay. And at the end, I will write CPU time minus time. Let's call it time 0 so that you can see. So this will give me at the end how much time it took to do this calculation. Okay, are you ready? 0.04 seconds. That's impressive. Let's do something less. Okay, 1.67. Okay. Can we do better? What would be your first suggestion to make it better?
Decrease the number of loops.
How?
You can break it.
Hmm?
You can break it. It won't go inside 7 times.
I can break the if. Very good. Very, very good. So, okay, let's break the if. How do I break the if? Let's then write a new version of it, okay? A new version of this code. I pressed, I think, Ctrl-Shift-S, okay, to make a new version of this file. What Özgün tells us, which is an Özgün idea, is to break it once you hit the first divisible thingy, okay? So I want to start with 2 now. No, do I? Yes, I do. I want to start with 2, and I will do something else. I will not go all the way up to n, I will go to n minus 1. Okay? No, I don't like it. Okay, let's go ahead and see what happens, and you will correct me if it's wrong. So Özgün, tell me, what do we do? If t gets 1, right, Özgün? If t gets 1, then break the cycle. Yes, you're right. Break. Thank you. And before I break, I have to do this, right? No, I do it here. Okay. Okay, by the way, it was like this, right? Then I pressed something and it got prettier. What did I press? Control I, okay? It gets all the nice indentations. Let's make it like this and choose everything. Control I, everything is back in the place. Yes? Will it work, Özgün? It should. Let's try with smaller numbers. It's not working. Tell me why. Yeah, what?
Everything has one division.
Well, I tried to avoid that by this n minus 1. Everything will break, you're right. So I have to go here and say, like, if t is 0, okay, so I will put t equals t plus 1. If it didn't break, then it is a prime number. Is this better? Yes. Look what happened with time. Okay, we have to try. Did we try 10,000? And what was the result? 1.67. Let's see if it's better. Well, it's better. But can we do even better? This is teaching coding, right? Can we do better? Mert, any ideas? Mert ideas this time. Bold, magnificent.
We first need to get rid of the inner folder for the first in order to improve it.
Okay.
Or we can use a range.
What about the following? What about if I go not all the way to n minus 1? Notice that when you are a prime number, you will not be divisible by anything between 1 and yourself, right? So even when we are in 10,000, I have to go from 1 to 10,000. However, I know that if I didn't find any divisible thing between 1 and my square root, there can be no other divisor after that. Because, do you get what I'm saying? Yes or no? Think about it. But what I will do is ceiling of the square root of n. Okay? Are you with me? Ready? Go. 10 times faster. Okay. Now is the time for this one. Let's see if it will work. It works, right? So let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I'm looking for 10. I'm checking 10, right? What's the square rootish of 10? It's 3 or 4. So 10 is divisible by 2, but when you divide it, you get 5. So everything below square root, if you find divisor there, then there's a divisor there. Okay. If there's a divisor here, there's a divisor here. And let's do it for 12.
Why?
5. Because okay,
Okay, I understand.
you don't understand it, right? 8, 9, 10, 11, 12. Okay. Now, can you? Oh, this looks very nice. Okay. So let's say we are checking 12. What is the square root of 12? Well, around 4, right? Uh, it's divisible by 2, and if you divide, it's over here, right? It's divisible. Okay.
So the square root, right?
Yes.
The mirror image.
Yes. And what a mirror it is, right? Okay. So, and square root is really nice. I mean, it's not like half of it. That's why it gets 10 times faster. So if it's 10,000, imagine what you are gaining. You just need to go all the way up to 100, right? While otherwise you had to go from 100, you had to continue from 100 to 10,000. You understand the point? Are you happy? Yes? Good. Well, there is a way to make it even better. I'm happy too, especially with this technology. So, there is a way to make it better. And what you do is, you don't divide with every number, but you divide with the primes that you have already found. Okay? You don't need to look anywhere else. So, like, if it's, okay, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's skip the non-primes. Well, let's make it 13. You just need to check whether 13 is divisible by 2, by 3, and that's it. You don't need to choose, okay. Let's go all the way up to 20, okay. Okay. Let's go from 1 to 100. You need to check from 1 to 10, right? But you don't need to check 10 itself. You just need to check the prime numbers in between, like 2, 3, 5, and 7. If it's divisible by one of these, it's done. So I happen to have a code that already has that. And it's over here. Okay?
By the way, may I ask something?
Yes.
The last thing we did before this, it skipped 2 somehow.
Ah, did it? Mm.
It should be a 7. Yes.
Well, yeah, you're right. But that's not the end of the world, right? And that's why I think I start with 2 here in the best code that I can write. Okay, let's go over this code. This code actually finds not the primes between 1 and 100,000, but it finds the first 100,000 primes. Okay? It works in a different fashion. So we start with t equals 1 and n equals 2. N becomes 3 later on. Blah, blah, blah. You have the square root n over here, break and everything, all kinds of beauty. But what it is looking after is the primes that it already found. It's only checking the primes that it already found. Okay? Since everything is recording, you can check out this program on your own time. And let me just show you how this program finds the first 100,000 primes in just 2.37 seconds. This is really nice. Okay. Uh, do you feel like you are more comfortable with MATLAB coding now? Yes? No?
May I ask
Hmm.
something? So isn't this longer than
No, it's okay. We are comparing two very uncomparable things. So
okay.
this was looking for prime numbers between 2 and 10,000. That's the first. And let's see how many of them it found. It finds only 1,228 of them. The other one finds 100,000 of them. To make it comparable, we have to go, okay. So it finds approximately 10,000 in 0.5 seconds. The other one finds 10,000 prime numbers. Well, it's comparable. um, but it's faster, right? Well, what you could do is, and we will see it hopefully. I'm going really slow today, but if you write the proper program down, we will see that sometimes things get diverged, the time scales get diverged if you increase the time. Okay. Okay. Like, for example, right now we are comparing 10,000 with 10,000, right? What if we indeed compare 100,000, which is 2.8 seconds here? And to find 100,000 here, I need to check. We will look for this number over here. What is it? It's not even 100,000, but it took it 6.3 seconds. So as you increase the numbers that you are spanning, the looking for just the primes gets advantages and advantage, right? But I feel like some of you uh, like are not happy with MATLAB introduction, right? No? Too complicated? Maybe in the next thing that we do, and the next thing that we do, will make it better.
Also, like Coursera has a nice introductory MATLAB. It's very, it's a nice base and very good.
Okay. And YouTube in general, right?
But the course is more structured than Coursera.
Okay. Okay, let's go back to computational universe and that stuff. So we will start by doing this experiment by Wolfram. Okay, do you remember this one? So we will be dealing with cellular automaton. Okay. Can you do you have like notebooks with you, or never mind? So let me explain you what's going on here. Are you with me? Let's make it big screen. By the way, are we recording? Yes, we are recording. Okay, so this is one particular rule, and we will write a general code that would change the rules, etc. So if you see a white square here, it's 0, right? If you see non-white square, then it's 1, okay? And these are the possible triplets, like it could be 111, 110, 101, etc., right? And if you choose any one of these triples, you can only have these 8 possibilities. Are you with me? Yes? And the rule defines what comes underneath this central one in the next generation. Like, for example, over here you have 3 of them, right? And all of them are 0. So the rule says that the next one should be 0. That's why the one underneath is 0, right? What about this one? 0, 1, 0. Let's go here. Where is it? 0, 1, 0. The one underneath should be 1, and this is 1. Do you see it? Yes? And, well, what comes next is really impressive. As I mentioned before, by just these simple rules, you get something that is totally random. Okay? In fact, like these places are totally random. I think Mathematica used this as a random number generator for 25 years, and it has been retired very recently because they found a better algorithm to generate random numbers. But this has served for a lot of time. So let's try coding this. Okay. So I start with clear. Okay. What clear does? It clears. You see this stuff here. If I run this code, okay, let's give it a name. Rules version 1. It clears everything, right? Let's now define a matrix. For example, over here you have 1, 2, 3, 4, 5, etc. number of cells, right? Let's say this is n, okay? So, and let n be 100, okay? If let's make it 101, okay? And let's say p is zeros of n 1, no, 1n, sorry. Let's see what happens if we run this. It gives me p that has a dimension of 1 cross 101, and it's all zeros all over the place, right? But we need that 1, 1, right? So I will write down 1 n plus 1 over 2 equals 1. If I run this, then you will see that this one is 1, okay? I can even plot it for you with this nice function, image scale, I believe. It's not Seymour Jahangirov, right? Let's make axis equal and none. First make it equal, then erase them. No, didn't work. Axis off. That's better. Do you see it? All blue except for this yellow here. Do you see it very clearly, everyone? Yes? Good. Now, yes. Okay. Okay. Let me just. Do you know how to do this? I don't know. I don't know. Anyways, if you even press this one, it works. But for me, I have
Shift 5.
Shift 5.
Yes.
Shift 5.
In Win. I thought you were saying I don't know how to do it.
No. Not this percentage, but if I press some shortcut, then it not only gives me this percentage, but it also gives me this nice emptiness. And besides, even better is I can choose something and just press this one and it will Control R.
Yes.
Thank you very much. Try Control R, please. And you get back Control T.
Yes.
Yes, very good. Okay, so now you need to. Okay, we really. Okay, can I delete it? Yes. Let's make it bigger. Okay, so let's say I have this string of 0, 0, 0, 0, 0, 1, 0, 0. Okay, and I want to find the next one. Okay, to find the next one, I have to shift it to the left. 0, 0, 0. And to the right. Okay, then this one will appear also here. Is that the case? Why not? It appears over here. I don't like it. Okay, let me tell you why. Okay, I hope I can do it. It's tricky. Let's take this one. Ooh, there it is. I should have done it this way. So then you can see that, let's make it like this one is the same as this one, right? But why I'm doing this? I'm going somewhere, okay, with this. So there are 8 rules, 8 possibilities, 8 like there could be 0, 0, 0, 0, 0, 1, all the way up to I believe 1, 1, 0 and 1, 1, 1. You can always make it into from binary to decimal, like 0, 1, and this one is 6. This one is 7. Okay. So if I multiply this one with 1, this one with 2, and this one with 4, I get myself 2, which is 0, 1, 2, 0, 1, 0, or 0, 1, 0. You get what I did? No? 0 multiplied by 1, what do you get? 0. 1 multiplied by 2, 2. 0 multiplied by 4, 0. So sum them up, you get 2, right? So we will assign some rules, right? The rule 30 corresponds to some rule that takes, like, if it's 1, 1, 1, then it's, I'm not sure right now, but I think it's 0, etc. Right? Is it confusing already? Do we need a break right now? Let's have a break. Okay. Okay, let me stop.